Good morning.
Good morning, Matt.
I'm looking forward to our next steps. What is on tap today?
Well, we want to talk a little bit more about derivatives. And so far, we've only talked about the first derivative of a function. But if you take a derivative of a function, you get another function. So that function also has a derivative, and that results in a function, which you can also differentiate. So what we really want is some sort of language or notation so that we can talk about a function and its derivative, and then the derivative of the derivative, and the derivative of the derivative of the derivative, because I don't want to have to say the derivative of the derivative of the derivative of the derivative of the derivative. I'll go
Okay,
crazy.
I agree with your idea is a good one. Let's have some geometrical intuition. So f is a function.
This is only notation, okay? So f is a function.
And what's f prime?
F prime is, remember, is the function that we get when we try to get the best linear approximation. Now, I know you're jumping ahead because you want to say, well, what is the second derivative? Give us the best of.
Yes, what does it?
Okay, just because you want to say it's going to tell us the best second order approximation. And this is going to lead to Taylor polynomials. But first, before we do that,
let's see what you got on
let's
tap.
do some notation. So we start with a function. And usually it's something like f of x. Then its derivative. And we had notation for that. Let's not worry about what it is just now. It's just f prime of x.
I bet you're going to have two dashes for the next one.
That's right. So the second derivative will have two dashes because it's the prime of the prime. So this is called the second derivative.
And rather than writing down 3, why don't you write down n for any derivative?
Well, I'm going to do 3 because I'm going to do a table.
Oh, you're going to do a table. Okay.
And then I'll do the nth one. Then there's the nth derivative. So this guy is easy because I can just use 3 primes.
Yeah, but you can't use n. N is a variable.
N would be go
so they put an n there.
And to make it clear that we're doing derivatives, we usually put the n in brackets.
Oh, that's good. Rather than power. So we
don't think of it as a power. It's not a power, right? It's just repeating the derivatives.
That's why you have to put the brackets in.
So let's do some examples. Here's a nice function, x to the 4. Do you remember what its derivative is?
4x cubed.
4x cubed. And we can differentiate that.
12x squared.
And maybe you can explain, where did that 12 come from?
Well, we take the 4 out and we differentiate x cubed. And x cubed, we know from previous, is 3x squared. So 3 times 4 is 12.
There you go.
12x squared. Well, now, x squared is differentiated as 2x, so the 2 goes with the 12, we get 24x.
And if I did it again, what's the derivative of 24x?
It would be 24, but if it was bigger than the fourth derivative, it would be 0.
And what's the derivative of 0?
0.
And what's the derivative of 0?
Oh, come on.
Okay, let's do another one. So it's interesting, you start off with x to the 4th, and eventually you get to 0. If I put x to the 10th, would I eventually get to 0?
Sure.
It would take longer.
Take longer.
So let's do sine x, because we like sine x. Do you remember the derivative of sine x?
Cosine x.
Cosine x. Derivative of cosine x?
Minus sine x.
Minus sine x.
So I want to say something about this. Sine near 0, sine is increasing, and then the slope is cosine x.
Mm-hmm.
And then cosine x is at the top of its value at 0, and then it starts to dip, so we got a minus sign.
A minus sign, exactly.
So you can think of it like a roller coaster.
It is a bit like a roller coaster, going up and down and up, down. And cosine starts at the top and goes down, negative slope.
So now we can continue.
Derivative of a minus sign.
It's going to be minus times cosine.
And then if I differentiate again,
you're going to get plus sign this time.
Sign. So this never goes to 0. It just repeats sines and cosines. Maybe let's do one more for fun. E to the x. What's the derivative of e to the x?
E to the x.
And what's the derivative of e to the x?
E to the x.
And what's the derivative of e to the x?
It's very weird, actually, when you do it like that.
That's a very weird function, but the exponential is a very funny function that every time you differentiate it,
you get it
back.
Of course, if you put a number here, then the numbers would pop down.
And that's a little bit of the chain rule, so that's a little bit tricky, but yeah, true.
Good stuff.